Okay, so let's go through the homework today. We were to write a program that gives like the best change for the some number of pennies, right? So we're going to be practicing a whole bunch of variables, and this was your starting point, right? All right, so we're going to have a variable here that starts off holding some number of pennies. Okay, then we're going to whittle this down, so we're going to have number of dollars, number of quarters, number of dimes, number of nickels, and then finally number of pennies will be whittled down. So I gave you a starting point here where we calculate the number of dollars is equal to the current value of number of pennies divided by 100. Okay? And using this double slash here, that gives you a whole number. So it does integer division rather than decimal division. Okay? So make sure you use the slash there. Then, for number of pennies, I'm going to take the current number of pennies and give you the remainder after I divide by 100. That's the number of pennies I have left over. Make sense? All right. So next thing would be number of quarters. And you don't have to write it this exact way, but I'm just going to create a whole bunch of variables, and then I'll print each of those variables. Okay? So number of quarters is going to be equal to the current number of pennies divided by 25. Then I will whittle down my pennies again. Okay, so pennies become smaller right here. I really have an unfortunate typo there, don't I? Okay, so number of pennies becomes smaller right here, becomes smaller again here. Now we'll do number of dimes, and that is equal to number of pennies divided by 10. Then number of pennies is equal to number of pennies mod 10. Give me the remainder. Okay. Then number of nickels is equal to number of pennies divided by 5. Then number of pennies is equal to number of pennies mod 5. So at this point, I've got my dollars, I've got my quarters, I've got my dimes, I've got my nickels. I mean, you could name these whatever you want, but I'm going to try to name them appropriately. I got my nickels, and then what's left over in pennies is my pennies. I've whittled pennies down over and over and over again until at this point what I have left in pennies is my final number of pennies. Okay? So now we're going to go ahead and print these out. Now this was something that you learned in the book for displaying stuff with stuff being on the same line. Now, it would have been acceptable for the homework for you to just print out like this. You could have printed out number of dollars, print number of quarters, print number of dimes, print number of nickels, print number of pennies. Okay, and maybe if you wanted to give a little bit of labeling, you should have said something like print dollars, like that. But this would have been sufficient. What I wanted you to do is show me your work with the math and variables. Okay, so if your output wasn't as pretty as it could have been, it's not the end of the world. So let me just paste these in here, and I'll change the letters up. So this is dollars, this is quarters, dimes, nickels, and finally pennies. All right, so and I want to drive another point home based on some of the questions that I've been getting about getting your stuff working, okay? So, first of all, somebody tell me, what is Atom? If you had to describe Atom to me, what would you say? Go ahead. Okay, Atom's a text editor. What does that mean? Give me some other text editors people may have heard of. So like Notepad? So Notepad is like the kind of the default text editor in on Windows. You also have WordPad. That's on Windows as well. Go ahead.
Is it an IDE?
It would be fair to call it an IDE, but put a pin in that for right now. Yeah, I want to really focus on the concept that it's just a text editor. Notepads, or whether you're talking about Notepad, or you're talking about Atom, or you're talking about Sublime, there's all these different text editors out there. The job of a text editor is to allow you to type some text and save it as a file. That's it. Okay? Now, a weakness of Notepad, the reason why we're not using Notepad, well, first of all, Notepad's just on Windows. Mac has something called text editor or something like that. But the weakness of those guys is their job is by default to save .txt files, text files. So in order to name your file something.py, you have to do a little bit of a kind of a trick. You got to change it to all files and then name it py. So completely doable, but not super convenient. All right. Text editors like Atom don't make an assumption of what kind of file you're storing. All right, that makes sense? All right, so it makes it very convenient for us to name our file .py for writing Python code, .c if we're writing a C program, .cpp if we're writing a C++ program, .java if we're doing a Java program. Make sense? It allows us to put the correct extension onto the end of it. Now, when we talk about that extension, I want to connect a few dots here just based on some of the questions. So when we have the .py extension, this tells the computer that this is a Python file. Now this type of thing here is something known as a MIME type. How many of you have heard of MIME types before? Okay. You've all dealt with them before. So for instance, if you get an email that has a file in it that's something .doc or .docx, what kind of file is that? It's a Microsoft Word file, right? Microsoft Word file is a .doc or a .docx. Okay? You just did the MIME type lookup. You looked at the end of the file and said, I recognize that kind of file. If the person double clicks on it, I'm going to go ahead and open it up in Microsoft Word or whatever the equivalent of that is on my computer. If you're on a Windows machine, you don't have Word installed, it'll open it up in WordPad, which is pre-installed on Windows. That makes sense? Okay, so MIME type is just a fancy way of saying we're going to take a peek at your extension on your file to figure out, to see if we can make a good guess on what kind of file it is. Make sense? Python files need to end in .py to label them as a Python file. Now you actually saw this in the tutorial when you did this, especially for the Windows folks, where they had you put at the top the #bin/python blah blah blah, where you could actually run your file directly by just saying ./myprogram.py, because you were running it as a normal Unix script at that point. I don't run my Python programs like that. I specifically run it through the interpreter to really drive that point home that Python is an interpreted language. We use the program called Python, which is the Python interpreter. I feed it the .py file, which is my Python code, and I say, I want you to interpret this guy. Make sense? All right. So that was the whole purpose of getting that Python command into your path on your Cygwin or on your terminal on Mac, so that when you come out here to terminal, and you type in Python, it finds it. All right, I'm just going to put some stuff on the end here that it won't find this. unless I just got real lucky. Okay, so if I press enter on that and it says command not found, that means it looked everywhere it could look inside of my path. And my path variable on my operating system is a variable that holds all of the directories that it will check for the executable things you might run. That makes sense? So when you were going through the tutorial and you did that whole echo path equals, you were changing the value of a variable. Variable name equals whatever its current value was, followed by the location of where you just installed Python. That's what you did. You added to your path the directory where you installed Python so that when you do type in Python, it will find it. Make sense? Okay. Secondarily, whenever I type in Python 3 on my computer, for most of you, definitely the Windows people, your version of this command is just Python. All right, because I'm on a Mac, Macs come default with Python 2.7 installed. I'm teaching this class as Python 3, which sometimes there will be a difference. In fact, in today's homework, there would have been a difference. The mod symbol is different between the two of them. But some of you, when you installed on your Mac, you just overwrote your Python 2.7, and now your Python command is actually Python 3. That's okay. No problem. Okay? All I want you to do is make sure that whatever Python command you're using on your computer, it's Python 3 point something. So on my machine here, if I type in Python -- version, I press enter, it's going to tell me this is actually my 2.7 Python. Okay? But if I type in Python 3 and press enter, it'll tell me, that version of it is Python 3.6. I keep both of them on my machine. All right, because I do a lot of development for different things, so I just want both. Okay, so that's the conversion I want you to make sure you make in your head, that when you see me type in Python 3, even though for a large percentage of the stuff we write, Python or Python 3 on my machine would likely work, because there isn't drastic differences between the two languages, just little things that become kind of headaches. When I type in Python 3, more than likely on your machine, it'll be Python. Make sense? All right, but to run a Python program, so there's another thing I want to cover here. So Adam, just a text editor. This guy's job is to allow you to type, from our perspective, your .py files. And as soon as you save the file as a .py, so the very first thing I would do whenever you create a new file for your homework or something like that in Adam, immediately name that file. Name it whatever .py, homework3.py, something like that. Don't put spaces in the name. Probably will work, but don't do it. Keep your names with no spaces. Homework3, no spaces, okay? But name it that right away and save it, because what that'll do is it'll put Adam in the mode of Python. So Adam is a more powerful text editor than just plain Jane Notepad. Notepad lets you just write text. It doesn't care what kind of text you're writing or whatever, but Adam is designed for programmers, for people who write scripts, for a lot of web programming type things, stuff like that. So it has built into it formatting rules for a whole bunch of different languages. So if you name your file, in this case I named mine test.py, it notices the MIME type of this file as a Python file because it sees the .py, and it will treat my code as Python code. That is built-in functions. It will highlight, it'll do indentation for me when I do like if statements or for loops or stuff like that. So it'll treat it as Python friendly. If you haven't named your code .py, it won't do special indentation. Make sense? So if you've either haven't saved it yet or you forgot the py on the end of the file, it's fine. It'll let you type stuff, but it's not going to help you. It's not going to be your friend for highlighting things and stuff like that. Does that make sense? Several of the folks that have brought code to me to look at have been showing me files that do not have a py on the end of it. Make that a priority. When you save your file, save it as .py. Also understand that Adam has very, 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 very little to do with Python. Okay? In fact, from a text editor perspective, I would say a text editor has nothing to do with Python. It just so happens that Atom was built with Python developers in mind and will do some color coding and auto indentation stuff for you as long as you play by their rules by putting the .py on the end of your file, okay? But Python or Atom doesn't have anything to do with it. Having said that, there are some things if you explore these menus up here where it will let you try to do some stuff. I'm going to tell you don't do that. We're using it just as a text editor in here. Go ahead.
Oh, I was just going to say on the bottom right, it says like UTF-8, and then when you first start, it says plain text. If you click on that, you can change the Python without having to save it.
Yeah, that's fine. But save it as .py. Yeah, he's saying you can modify it down here and tell it what it actually is. So you can help it make those mime decisions in the event that it wasn't able to do it automatically. But you should never have to mess with that. Name your file something .py and life will be easy. All right, but the role for us, the reason we are using Atom is to type our Python code. That's it. Make sense? So we'll call this our tools. Atom allows us to type and save .py files that we will later run at the command line using our Python interpreter. Okay, now he mentioned something called an IDE, which is it's an integrated development environment. We'll be using those in 250 when we get to a Java, which kind of takes this idea of a text editor that helps us a little bit with Python to the next level where it helps us a lot with Python. Okay, and one of the things it'll have built into it usually is a little play button that you just hit and it runs the Python program. Keeps us from having to go out to the terminal and running it through the interpreter. That's all fine and dandy, and that's going to be really helpful when you become a more accomplished programmer. But as beginning programmers here, we want to be used to what's actually happening under the hood. Okay, because I promise you, all that IDE is doing is it's going to the command line in the background and running your script through the Python interpreter. It's doing the work that you're doing manually right now for you. Okay. Also, having this skill set in command line stuff, super important today. Some of you are going to become web developers or become script writers for loosely typed languages or interpreted languages. You're going to spend a lot of time out here at a Unix terminal. And outside of a few of you, I'm willing to guess that most of you have had little or no experience with command line stuff, right? How many of you in here have ever done anything with a Unix command line before this class? Okay, so we have 2 1/3 people. We had a little mini hand up. Okay. How many of you have done something with a DOS command line in here? Okay, so this would be like on a Windows machine where you could type in dir and press enter. Okay, even very few of you for that, right? Okay, that used to be the only way you would use your Microsoft operating systems. The operating system was DOS, disk operating system. All right, so then all of a sudden they slammed a graphical user interface on top of it. Now we are good at using the mouse and we double click on stuff and things like that. And that's fine. It's made our life easier. But as technologists and as computer scientists, we are experts at using the tools, right? Okay. You know, when you're at your house, let's just take the average person. How many of you would consider yourself a professional plumber? None of us? Okay. Probably not going to go down and do a whole lot of messing around with the pipes. We kind of appreciate that they're there. In fact, if you're in a house that doesn't have an open ceiling in a basement or something, you may never even see the pipes, right? Unless maybe you peek under the sink or something. But you trust that they're there. But as users of those pipes, you know, we have our sinks. We turn a little knob, double clicking with the mouse, right? Turn a little knob. Shower, turn the little knob. We're users of that. But in here, we're trying to become professional computer scientists. Just like a plumber, his job is to work directly with the pipes, right? You have a problem with your plumbing at your house, you bring in a professional, charges you a lot of money, but he's doing something that you don't want to be messing with. Okay? I have a buddy who's quite handy. He does all my boat engine maintenance work and stuff like that. Former student, actually. And this guy's handy. He won't touch plumbing. And he'll touch electrical, but he probably shouldn't be doing that either. But plumbing, you don't want water all over your house. Bring in the pros. All right, so we're trying to become the technology version of the professional plumber. Okay, we're going to become computer scientists. We need to be able to use the tools of our trade that the average Joe, okay, isn't going to be using. That make sense? All right, so I know the command line's intimidating for you right now. Get used to using it and don't try to avoid it. You're only hurting yourself. Okay, a couple of you have come up and asked like, oh, well, I have this other tool that has a little play button that'll just let me run my Python program. That's fine. I mean, if that makes you happy, whatever. But you're only hurting yourself because you're losing out on that practice with the command line. All right. Another question people ask, why did I have to install Cygwin on specifically on a Windows machine as opposed to using the DOS prompt the command prompt on a Windows machine? You actually don't have to, but the reason you use Cygwin is because now you're using a Unix command line. Okay, so you're learning about Unix commands. LS for a directory listing, CD into stuff. There's some text, a couple of you saw me open up like a text editor out there called VI, which very old school text editor. You may never want to work with that, but sometimes you aren't going to have the pleasure of being able to open up a graphic user interface text editor. Maybe you'll be remoted into a router somewhere or something like that that's under the floorboards halfway across the building, and you're not going to have a little keyboard and mouse available to that guy, and you're going to have to do everything from the command line. All right, so this is a skill you want to have, and almost every one of those machines are going to be running Unix or Linux. All right, so having this skill set will be beneficial. And we're only getting the tip of the iceberg here with your basic commands for Unix or Linux. I promise you that it's really powerful. You can do some pretty cool stuff with it, where you can string commands together and way more than you can do with DOS. Okay, so don't avoid that. All right, so Adam, this is the graphical user interface tool that we're using to type our programs out. Okay, our terminal or Cygwin, this is our Unix compatible command line that we will use to launch our Python interpreter on our file we wrote in Atom. Okay? Super, super important note here. You must be sitting in the directory where your .py file lives before you can run the interpreter on it. That's actually a half-truth because you could give it the full path to where the file lives, but for us right now, you need to be sitting in that directory. Okay? And what does that mean? That means when you type ls, you should see your .py file listed. If you don't, you need to use the cd command to move into the directory where your file lives. So when you use Atom to write your Python file and you save it, you need to save it to a place that you can get to conveniently in Cygwin. Okay? When you first get into Cygwin, I'm doing this for my Mac terminal here, but these are all Unix compatible. So the commands I type in here, you can type in on Cygwin. You can't type them in on the DOS command prompt. So if you want to know where am I currently sitting on my Unix system, if you type in pwd, This is print working directory or present working directory, and press enter. It'll tell you where you're currently living. So on my Mac, I'm sitting in /users, /awesomefat, /desktop. So anything I put on my desktop, it'll show up here. Now, one little weird thing that you will have with SIGWin is you have something called like a SIG drive /C. So that's the starting point to get you to your C drive on your computer for SIGWin. It's just how it hacks the Unix terminal on top of your file system. Because when I'm looking at, on a Mac is built on top of Unix. So I'm actually looking at my actual file system. There is no such thing as a C drive on a Mac. Okay, the C drive on my machine is /. Okay, it's a POSIX-based file system, Unix system that looks like this. Okay, now from anywhere in the computer, if you want to get back to your home directory, you just type CD, press enter. You can also type CD space and put the little tilde guy, little squiggly. That'll take you back to your home directory as well. So that's my home directory. Good.
How do you change your home directory?
You can change it if you look in here. Don't do this, by the way. It's just going to make your life that much harder right now. But from your home directory, if you do an ls space -a, it'll show you all the files, including the hidden files. In Unix, there's a bunch of files that have a little dot in front of them. So see all these guys here, these little dot files. And you're going to have less files, probably, because you haven't put as much stuff in there yet. But you have this thing called bash profile. And there's a bash RC somewhere. So in your bash profile will be where you can tell it the location of your home directory. But you probably want your home directory to be the default home directory and get used to using that. I'm guessing where you were going is if you can change it to a convenient place that you put your stuff, so you could just type CD and press enter. Yeah, not a bad idea from a productivity perspective, but it's going to do you some good right now to get used to walking the directory structure and making sure you move into a place where your file lives. That makes sense? So right now, my present working directory is here. Let me go and look at where I saved this file. I saved it on my desktop. All right. So if I want to try to run my Python interpreter on this guy, I say Python test py, it's going to say, can't find this file, can't open file, blah, 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 blah. How many of you have seen this error? Several of you, right? Okay, that's because if I type in ls, I won't find my Python py file in there. If I want to help my ls a little bit, I can say ls star.py, and this will show me all of the Python files in the current directory. All right. Similarly, I can say ls. I'm just going to show you some stuff you can do with Unix. I can pipe that output to another command called grep and do a search for star.py. And you can do way more complex things than that. I'm just telling you the Unix command line is powerful. You can do stuff here that you can't do with a graphic user interface. Go ahead.
Is there a command that lets you tell it to look in a directory for a Python file and run it? Instead of having it be in that directory?
You could write a script that does that. Yeah, basically anything that you think could be a convenience, you can probably do in a Unix command line. But right now, we're staying real vanilla. Okay. We're going to change directory into the directory where our file lives, so we know that our directory where my file is saved is the desktop. And I know that the desktop, if I type ls here, is actually a directory right off of my home directory on my computer. Okay. On Windows machines, it'll probably be /sigwin, /c, /users, /whatever your username is, /desktop, or something in that ballpark. All right, so store your file in a place that you can conveniently get to. Okay, so I'll just move myself into the / directory so I'm not one step away from this. Okay, so if I type present working directory, it looks like this. So I need to go into my users directory first. So I'll type cd users. Now, you can do this on Cygwin as well. Notice I typed it. It is it is case sensitive, so it cares. So I just started typing US, and I pressed tab, and it filled in the rest of it for me. You can make multiple jumps at once, but I'm going to suggest for a little bit you just take one hop at a time, okay? Because I can go ahead and type in. I can go to users / awesomefat / desktop all in one leap if I wanted to. But until you get used to this, I'm just going to jump into the users directory. Now I'm there. Do ls, it's going to show me all the users on here. Then I'm going to go into the awesomefat directory. Type ls, it's going to take me there. This is the same place that just typing cd, press, and enter took me, because this is where my home directory is. Then I'm going to type cd desktop. It's going to take me here. I have a bunch of stuff on my desktop, so if I want to just make sure the Python file is there that I'm looking for, I'm going to type ls space star.py. This says show me all the files that end in .py. And I see my file there. Test.py, that's the dude I want to run. So I'll type python3 test.py, run it, and there is my output. Make sense? All right, so I just gave you the entire workflow of writing Python code, then running Python code. Everybody's following that? Now, if I have a bug, if I have a problem with my code, so let's go and do this. I'm gonna introduce a bug. Here, we'll forget a double quote there. I'm gonna save this, so anytime you make a change to your file, you need to save it. Then you can come back out to your terminal. Now, the good news is we're already where we need to be. All right, we're already there. So I don't need to change back into the directories or anything. So as long as you don't shut down Cygwin, you can just go right back here. You just had to do the work initially to move you to the place. Now I'm standing in the room where my file is. So Cygwin lets you press the up arrow, and that'll show you the file, the command you previously typed. Okay? You might want to type it by hand several times just to kind of get used to doing command line stuff. But after a while, you can go through that. Once you have 1,000 commands, you can actually type in history, and that'll show you all the commands you've ever had. This boot, and command 531 was the command I wanted, so I can do bang 531, and that will run that command. These are not things I'm suggesting you do. I'm just kind of showing you how flexible flexible/powerful the command line can be. Okay? So I effectively typed in python3 space test.py, and it's yelling at me and saying, hey, end of line while scanning string literal, because I forgot my double quote here. Make sense? All right, so I'll go ahead and put that guy back in here. All right, now, to get the output the way we maybe really wanted it, what's our trick for getting this dollars to print on a line without kicking it down to the next line that you learned in the book? You do a comma.
End line.
Okay, so end equals, and then you can just do that if you want to. I think the book maybe has you do single quotes. The book might do that, which is just a char, but it doesn't matter. This is saying, what do you want the end of your line to actually be, rather than the default, which is carriage return. So I'll just copy that. I'll put it on the end of all my prompts. And this is just a formatting thing, right? All this is going to do is it's going to put dollars followed by a space on a single line without pressing enter. So when I print out my number of dollars, it'll just be right next to it on the same line. Save the file again. Always save before you go and run it again. Go back out here to my terminal, run the file. There's dollars, quarters, dimes, nickels, pennies. Make sense? Now, if we wanted to just make sure we're testing this correctly, what we might do is maybe put up top before we change number of pennies, maybe we do a print original pennies. And then I'll just steal this number of pennies line. If I were you, I would do as little copying and pasting as possible so you get used to typing stuff and not making errors. All right, I might do some copying and pasting for time. I've done this a few times. All right, so now I'm just gonna, this kind of tells me where did I start so I can kind of check my work. Okay, so if I started with 1,013 pennies, does 10 $1 bills, a dime, and 3 pennies make sense? Sounds good? Okay. If I change this to 21,714, so all I did is change my very first number. Make sure you save it. Come out here, run it again. $217, blah, blah, blah.
Okay.
Make sense?
Yeah.
All right, so you test this in any number of things you want, but this guy works now. Okay? Now, the book, I think one of the things you read also had you do some input, right? Where you can read something in from the user. Okay, so right now, we are just doing this once. So anytime I want to change something, I come in here and let me just put 13 in here. Now, just to show you what will happen, I'm not going to save this. I forgot to save. So I'll come back out here, I'll run my program again. It's running it off of the 21,714. You have to remember to save your code and before you run it, otherwise it'll be running the last saved version. Now when I save it and run it, I get the correct thing here. If we want to actually see it with something with quarters and stuff, so let's just do 29. So that's 1 quarter, 4 pennies. Make sense? All right, now, anybody remember how you do input? If you want to read something in from the user? All right, but this is going to come in as a string. I want to turn it into an integer. So we have several functions in Python. So we're going to call these Python converters. We're going to introduce 2 of them today that are going to be helpful for us. We have the int function that turns a string into an int. It actually will turn anything that is intable into an int. But for right now, we're gonna be doing a lot with strings and integers over the next several weeks. Okay, so the int function turns a string into an int, and I'll put a little s in here. And the one I always say this turns the string s into an int, and then we have another function here called str. I'll have that guy take in. I'll just name the variable I. This guy turns the int I into a string. But this also works on anything that is stringable. So it'll work on floating point numbers and stuff like that. Chars. Okay? So when I read in the number of pennies here, I want to be able to do math on that guy. Right? So I can do this a couple different ways. We can take advantage of the fact that Python is a loosely typed language. So is number of pennies allowed to hold a string? It is. But I ultimately want it to hold a number because I want to do math with that dude, right? So I can do this. I can, on the very next line, I can say number of pennies is equal to the int version of number of pennies. That'll just turn it into a number. Make sense? Python makes it really easy to convert stuff into integers or into strings. Go ahead.
What's the benefit of doing the second line instead of just putting...
Yeah, you're right. I could just do it here. There is no real benefit. I can just wrap this entire thing in int. That's what you're getting at here? Yeah, I can do that whole thing as an int because remember, this guy, we're doing variable resolution. So that looks like way more than a variable, right? That's like a function call. Remember last time I was telling you that don't judge a book by its cover? So everything I've highlighted there, you look at and say, well, that's me input, prompting the user for some stuff. And then having them, in fact, I think in Python 2.7, it's prompt, not input, but whatever. That's me prompting the user for some stuff and then reading it in as a string. But ultimately, what does this boil down to? It boils down to a string. The string that we read in. Then I'm going to pass that guy to my int function. All right, so you ask, what's the benefit of this? The most correct way, let's say, of writing this is probably this line right here. But for some of you, maybe most of you, being beginning programmers, when you have to start stringing multiple functions together, it starts getting intimidating. Okay, so I might say for starters, take advantage of the fact that Python lets you hold different kinds of values inside of a variable. So go ahead and just read in your string with a single function, store it in your variable. Or if you didn't want to, you can call this guy temp string if you really wanted to. Name it something different. And then we can set number of pennies equal to the int version of temp string. Okay, go ahead.
Like you had before, you had the int input. What if the user inputs something that isn't?
Input, well, like hello.
Yeah.
Yeah, then it'll scream at us. Yeah.
Do that.
You can do error checking and stuff like that, but we're keeping it as simple as possible. But you're right. He said if the user enters something that it wouldn't, like if somebody gave you, a piece of paper that says hello world on it and they said convert that to an int, you'd look at them like they were crazy, right? Python will do the same thing. If you want it to convert to an int, assume they're entering in an integer. Yeah.
Is there an easier way for you to tell if there was an error in your program? Because I just sent it to sent it to Segwit and it usually came back with specific. It just came back with one specific line and it was wrong.
Yeah, that's a skill that you'll end up learning just from practice. Read that error message. They are meaningful,
yes,
but they're intimidating at first. So there's not an easier way right now. There are things called debuggers that kind of help you walk through the program, but they wouldn't be the appropriate tool for us to use right now anyways. Yeah, so the correct thing to do is look at the line that it's complaining about. The problem is either that line or something before it.
Yeah.
Because you might have screwed something up here that wasn't noticed until you went to do something with it down here.
That's what I mean.
Okay, so now we will read this in to temp string, convert it to number of pennies, and then do all the rest of the stuff. So I save this, I'll run this again. It wants me to enter in a number of pennies, so I'll do 129. I'll press enter. It converts that into an integer and then shows me that line. Make sense? Similarly, if I wanted to keep asking me this stuff, I can say, I want to do all of this stuff over and over and over again inside a while loop. While loops say repeat, right? A while loop will keep repeating as long as this Boolean expression boils down to true. Doesn't get any truer than just true. Okay, this is an infinite loop, probably not the best programming practice, but we'll go with it for right now just to show you this example. I'm basically saying this program runs until I do something to intercede and crash it. So now when I run this, it'll let me keep entering a number, 121, enter a number of pennies again, tap in some other thing, it does the math again, tap in some other thing, does the math again. If you want to type hello, now you get your crash. Okay, if you wanted to end it more gracefully, you can hit Control-C on the Unix prompt, and that will kill whatever command is currently running. All right, that makes sense? All right, so class is up, so I'm gonna think about it, but I'm gonna give you another programming assignment, kind of similar complexity to what we wrote for today, maybe with a little loopy stuff built into it or some user input stuff built into it. Okay? But not significantly more complex. I want you to practice with those variables and things like that and get more practice. I just don't have anything off the top of my head, and we're already out of time. So it'll be up in the next hour, hour and a half or so. Cool? Questions, comments, concerns, bribes? All right, I will see everybody on Monday.